Hello, science fans! Welcome to a journey into the world of the elements, where we're about to meet a true heavyweight, one that's sure to surprise you with its power and mystery. Today we're shining the spotlight on osmium, the densest naturally occurring element on Earth. If you've ever wondered what it would be like to hold a piece of pure, concentrated matter, osmium is as close as it gets. This element sits quietly on the periodic table, but its properties are anything but ordinary. Imagine picking up a sugar cube only to discover it weighs as much as a hefty bag of dog food. That's the kind of mind-bending density we're talking about. A small chunk of osmium can feel shockingly heavy, defying your expectations and making you question everything you know about weight and size. Osmium belongs to the exclusive platinum group, a family of metals known for their rarity, resilience, and unique characteristics. Among its siblings like platinum and iridium, osmium stands out as the most compact, the most tightly packed, and the most extreme in terms of density. When we talk about density, we're talking about how much mass is crammed into a certain space. Picture packing a suitcase so full that you can barely zip it shut. Osmium takes this idea to the next level, squeezing more atoms into a tiny space than any other element. On the atomic level, osmium's structure is a marvel. Its atoms are arranged in a way that leaves almost no empty space, making it the ultimate example of how tightly matter can be packed. This gives osmium its incredible weight and some truly fascinating physical properties. Visually, osmium is stunning, a bluish-white metal that gleams with a subtle, almost otherworldly shine. It's hard, brittle, and so rare that most people will never see a piece in person. Its rarity and beauty make it a prized possession for collectors and scientists alike. Try lifting a chunk of osmium, and you'll instantly feel the difference. It's as if you're holding a piece of another planet, so dense and heavy that it almost doesn't seem real. This element challenges our everyday sense of weight and mass, making it a true oddity in the world of materials. But osmium's density isn't just a fun fact for trivia night. It actually helps scientists unlock the secrets of matter itself. By studying how its atoms are packed, researchers gain insights into the forces that hold materials together and the limits of how dense matter can become. In this chapter, we'll compare osmium's density to everyday objects, apples, rocks, even other metals, so you can see just how extraordinary it is. You'll be amazed at how a tiny piece of osmium can outweigh much larger items you encounter every day. Imagine, for a moment, a giant chunk of osmium falling from space. The sheer weight and density would make it a force to be reckoned with, far heavier than any ordinary meteorite. It's a fun thought experiment that shows just how extreme this element really is. We'll also take a look at how scientists measure density in the lab. Using precision scales and careful calculations, they can determine exactly how much mass is packed into a given volume, revealing the secrets hidden within each tiny sample of osmium. But where does this rare metal come from? Osmium is found deep within the Earth, often alongside other platinum group metals. It's extracted from ores that are themselves incredibly scarce, making every gram of osmium a precious find. That scarcity is part of what makes osmium so special. It's one of the rarest elements in the Earth's crust, and its extraction is a complex, painstaking process. This rarity means that osmium is not just scientifically fascinating but also highly valuable. So get ready to have your mind expanded and your idea of heavy completely redefined. Osmium isn't just another element, it's a window into the extremes of our universe, a reminder of how much there is left to discover. Osmium is more than a dot on the periodic table, it's a testament to the diversity and wonder of our universe. Let's dive in and explore the incredible world of the heaviest element known to science. When we say osmium is dense, we mean it. This isn't just a scientific curiosity. It's a record-breaking fact that sets osmium apart from every other naturally occurring element on Earth. Imagine holding a chunk of metal in your hand that feels almost impossibly heavy for its size, as if it's defying your expectations of what metal should weigh. That's the osmium experience. Its density is so remarkable that even seasoned scientists are often surprised when they first handle it. Let's put this into perspective. Water's density is 1 gram per cubic centimeter, which is our baseline for most density comparisons. It's what we use to define the metric system's unit of mass and volume. Now take aluminum, a metal known for being lightweight and used in everything from soda cans to airplanes. Aluminum clocks in at about 2.7 grams per cubic centimeter, making it nearly 3 times denser than water, but still light enough to be easily lifted and shaped. Move up the scale to iron, the backbone of our buildings and infrastructure. Iron's density is 7.87 grams per cubic centimeter, over 7 times that of water. Then there's lead, famous for its heft and use in everything from weights to radiation shielding. Lead's density is 11.34 grams per cubic centimeter, making it one of the heaviest common metals you'll encounter. But osmium? Osmium takes things to a whole new level. Its density is a staggering 22.59 grams per cubic centimeter, over 22 times denser than water, and nearly 3 times denser than iron. If you had a cube of osmium just the size of a sugar cube, it would weigh as much as a large apple. That's how extreme this element is. Its closest rival in the density race is iridium, another rare and precious metal. Iridium comes close, but osmium just edges it out for the gold medal, holding the title of the densest naturally occurring element known to science. In the world of heavy metals, osmium stands alone at the top of the podium. To really grasp how dense osmium is, let's compare it to something even more familiar: the ground beneath our feet. The average density of the Earth's crust is about 2.7 grams per cubic centimeter, similar to aluminum. That means osmium is over 8 times denser than the very rocks and soil that make up our planet's surface. Even if we dig deep into the Earth, all the way to the core, we still don't find anything quite like osmium. The Earth's core, made mostly of iron and nickel under immense pressure, is only about 13 grams per cubic centimeter. Osmium leaves even the heart of our planet in the dust when it comes to density. So what gives osmium this incredible density? It all comes down to the building blocks of matter: atoms. Osmium's atoms are not only extremely heavy, but they're also packed together with almost no wasted space. This tight atomic arrangement is what makes osmium so uniquely dense. There's another twist: the lanthanide contraction. This phenomenon causes the electrons in osmium's atoms to be pulled closer to the nucleus, making the atoms themselves smaller and heavier than you'd expect. This effect is a subtle but powerful force in the periodic table, and it's a big reason why osmium is so dense. These compact, heavy atoms arrange themselves in a crystal structure that's incredibly efficient, leaving almost no empty space between them. The result is a metal that feels almost unnaturally heavy for its size, with a density that's unmatched by anything else you can hold in your hand. It's the perfect storm: heavy atoms, tight packing, and a unique place on the periodic table. All of this combines to make osmium the undisputed heavyweight champion of the elements, a true marvel of the material world. Numbers are great for understanding the world around us, but sometimes they don't quite capture the true feeling of something extraordinary. When it comes to osmium, the densest naturally occurring element, the numbers alone can be mind-boggling. But what does that actually mean in our everyday lives? How can we wrap our heads around just how heavy osmium really is? Imagine picking up something that looks familiar but is shockingly heavy. That's what it's like to handle osmium. Its weight is so surprising it can catch even the strongest person off guard. Take a 1-liter milk carton, something you might pour over your cereal every morning. If you filled that carton with osmium instead of milk, it would tip the scales at about 22.6 kilograms, almost 50 pounds. That's heavier than most toddlers, and you'd need both hands and a lot of effort just to lift it off the table. Now, picture a standard construction brick. Normally, it's easy to carry with one hand. But if that same brick were made of solid osmium, it would weigh nearly 100 pounds. That's as much as a large dog or a small adult packed into a brick-sized object. Even a handful of osmium pebbles would surprise you. They'd feel heavier than a big rock you might find in your garden, despite being much smaller. It's a weight that defies your expectations. Now let's go bigger. Imagine replacing the rubber in a car tire with osmium. That tire would suddenly weigh over 500 pounds, more than a grand piano. Moving it would be nearly impossible without heavy machinery. Or think about a soccer ball. If it were made of osmium, it would weigh a staggering 277 pounds, the combined weight of 2 average adults. Forget about kicking it. You'd need a team just to lift it. You couldn't kick it. You could barely roll it across the ground. Its density makes it feel almost glued to the spot. Osmium isn't just heavier than most metals. It's in a league of its own, setting the standard for density and weight. When you compare it to other heavy metals, osmium stands out as the true heavyweight champion of the periodic table. Imagine a school bus-sized chunk of osmium crashing to Earth. It would weigh nearly 1,500 tons, 3 times heavier than an iron meteorite of the same size. The impact would unleash far more energy, creating a massive crater and a blast like a nuclear bomb. Osmium's high melting point means it would resist vaporizing, but as it burns, it forms toxic osmium tetroxide gas. The explosion would vaporize the meteorite and part of the crust, sending toxic dust into the atmosphere. The result? Catastrophic local destruction and a global health hazard. After the explosion, osmium's density takes over. Unlike iron, osmium would sink rapidly through the molten rock, plowing downward through the crust and into the mantle. It would act like a cosmic bullet, burrowing toward Earth's core. Over thousands or millions of years it would pass through the mantle and outer core, finally settling at the solid inner core. There it would become a tiny, super-dense anomaly at the planet's center. How do scientists measure osmium's density? The classic method: measure mass, then volume by water displacement. For osmium, scientists use ultra-pure samples and precise scales. They measure volume with non-reactive liquids, then calculate density. For even more accuracy, they use X-ray crystallography, firing X-rays at a crystal to map its atomic structure. Knowing the mass and volume of the unit cell, they calculate density with astonishing precision. That's how osmium earned its crown as the densest element. Osmium is incredibly rare, about 50 parts per trillion in Earth's crust. You won't find it lying around, it's too scarce for everyday use. So where does it come from? Not from ordinary stars, but from cosmic collisions. When two neutron stars collide in a kilonova, they create the perfect conditions for heavy elements like osmium to form. The debris from these explosions seeded our solar system billions of years ago. Every atom of osmium is a relic of one of the universe's most violent events. Osmium isn't just dense, it's also extremely hard and brittle. It's tough to shape, and if struck, it shatters rather than bends. Its melting point is over 3,000 degrees Celsius, making it useful in high-heat applications. Osmium forms a toxic compound, osmium tetroxide, when heated in air. Despite its dangers, osmium alloys are used in fountain pen tips, electrical contacts, and medical implants. In chemistry, osmium tetroxide is a valuable catalyst and staining agent. It's a metal of extremes, rare, tough, and dangerous. Osmium's density is mind-blowing. A milk carton full would weigh as much as a child. Its unique atomic structure makes it the densest element, defying our intuition. An osmium meteorite would cause devastation, then sink to Earth's core. Osmium is a cosmic treasure, forged in neutron star collisions and scattered across the universe. Its rarity and extreme properties make it valuable for specialized uses. Osmium reminds us that the universe is full of wonders and extremes. Stay curious, there's always more to discover, from the lightest gas to the heaviest metal. Now that's science.